Hey everyone, welcome back to the channel. Today we're diving into the world of flat Earth theory. Now, I know what you're thinking. Haven't we figured this whole Earth-shaped thing out already? You'd think so, right? But the flat Earth theory persists, and it's more popular than you might imagine. So, let's explore the main arguments used by flat earthers and how they interpret their observations. Have you ever stood on a beach, looked out at the horizon and thought, seems pretty flat to me? That's the first point flat earthers often bring up. They argue that if the Earth were really a giant spinning sphere, we should see the curvature of the horizon, especially from high altitudes. Where's the curve? They ask. I've been on a plane and it looks flat from up there. Now, it's true that our eyes alone aren't sensitive enough to detect the Earth's curvature from those vantage points. But that doesn't mean it's not there. Think about an ant on a basketball. To that ant, the surface of the ball would seem pretty darn flat, right? It's all about scale. The Earth is so massive, its curvature is subtle, especially when viewed from close up. However, there are ways to observe the curvature. Surveyors, for example, have to factor in the Earth's curvature when making precise measurements over long distances. And of course, we have countless images from space that show our planet in all its spherical glory. I bet you didn't know why some people think the Earth is flat. This one's a popular argument among flat Earth proponents. If the Earth is curved, they say, why doesn't the horizon curve downward when I look out of an airplane window? Commercial airplanes fly at around 35,000 feet. That's quite low compared to the Earth's radius, which is roughly 4,000 miles. At that scale, 35,000 feet would be less than the thickness of a piece of paper. To see the Earth's curvature, you'd need to be much higher up. Think in orbit. Flat earthers often point to the fact that water always finds its level as proof that the Earth can't be curved. If the Earth were a sphere, they argue, wouldn't all the water bulge out at the equator and spill off into space? Well, first of all, let's remember that gravity is a thing, and gravity pulls everything, including water, towards the center of the Earth. So even though the Earth is spinning, the water isn't going to fly off. It's held in place by the Earth's gravitational pull. Secondly, water does curve. It just curves over such a vast distance that it's difficult to perceive with the naked eye. Think about the oceans. They cover massive portions of the Earth's surface, and their shape conforms to the Earth's curvature. We have satellite images and precise measurements that confirm this, so the next time you see a calm lake or a vast ocean, remember that the water isn't defying gravity or proving the Earth is flat. Ever wonder why some long-distance flights take seemingly roundabout routes? Flat earthers sure do. They point to these flight paths as evidence that the Earth must be flat. For example, they might ask, why would a flight from South America to Australia make a stopover in the Northern Hemisphere if the Earth were round? On a flat Earth map, these routes might seem more direct. But remember, we live on a sphere. And the shortest distance between 2 points on a sphere isn't always a straight line on a flat map. It's actually a curved line called a great circle. Airlines use these great circle routes to save time and fuel. It might seem counterintuitive, but flying over seemingly longer distances on a flat map can actually be the most efficient way to travel between 2 points on a spherical Earth. Plus, there are other factors that influence flight paths, such as wind patterns, air traffic control, and even political considerations. So the next time you're looking at a flight map and scratching your head, remember that there's a lot more going on than meets the eye. Now we're getting to the truly imaginative part of flat Earth theory, the ice wall. In many flat Earth models, Antarctica isn't a continent at the bottom of the globe. Instead, it's a giant, impenetrable wall of ice that surrounds the entire flat Earth, holding in the oceans like a giant bathtub. And who's guarding this ice wall, you ask? Well, that's where things get a little conspiratorial. Some flat earthers believe that governments and secret organizations are patrolling the ice wall to prevent anyone from reaching the edge and discovering the truth. Now, I have to admit, the idea of a giant ice wall surrounding the Earth is kind of cool. The Antarctic Treaty System, which governs international relations with respect to Antarctica, does impose some restrictions on activity there, but that's primarily for environmental protection and scientific research, not to hide the edge of the world. If the Earth is spinning at over 1,000 miles per hour, flat earthers often ask, why don't we feel it? Why aren't we flung off into space? It's a question that seems logical on the surface. After all, if you've ever been on a fast-spinning carnival ride, you know how disorienting and powerful that force can be. But here's the key difference. The Earth's rotation is constant and smooth. It's not like slamming on the gas pedal and feeling a sudden jolt of acceleration. We've been spinning along with the Earth since the moment we were born, so we don't feel the motion. Think about it this way. Imagine you're on a train moving at a constant speed in a straight line. If you close your eyes, you can't feel the movement unless the train speeds up, slows down, or changes direction. It's the same principle with the Earth's rotation. Gravity also plays a crucial role. It pulls everything towards the center of the Earth, keeping us firmly planted on the ground, even as we spin through space. The way the sun and moon move across the sky is another point of contention for flat earthers. They often propose a model where the sun and moon are much smaller and closer to Earth than in the heliocentric model. In this model, the sun acts like a spotlight, moving in a circular path above the flat Earth and illuminating different regions to create day and night. This explanation might seem plausible at first glance, but it doesn't hold up to scrutiny when you consider other celestial phenomena. For example, how do flat earthers explain lunar eclipses, where the Earth's shadow falls on the moon, or the phases of the moon, which are caused by the changing angles of sunlight reflecting off its surface? These events are perfectly explained by the heliocentric model, where the Earth and moon orbit the sun. The flat Earth model also struggles to explain the way the sun sets and rises. If the sun were simply a spotlight moving in a circle above a flat Earth, it wouldn't disappear below the horizon as we observe it. Flat earthers argue that objects disappearing over the horizon is due to perspective, not Earth's curvature. They claim human vision limits and light behavior create an illusion. But if Earth were flat, a powerful telescope should reveal the entire object. Instead, objects disappear bottom up due to Earth's curvature. The higher the vantage point, the farther we can see before the curvature obscures our view. So, there you have it, a whirlwind tour of some of the most common arguments used by flat earthers. Thanks for tuning in. If you enjoyed this video, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, stay curious.